Good morning, everyone. I'm not used to stay to a microphone, so I hope you hear me, because I might just move as well. Is that okay if I just, otherwise I can't speak if I don't move. I have a problem with connecting my feet with my brain. I'm Adrian Hornsby, I'm technical evangelist for AWS. A lot of people wonder what is a technical evangelist. I'm connecting developers, customers with our service team, so I'm the link between all that. I have a big developer background, and I love talking about technology. So it was perfect match for that role. I have some problems here. I can't see my screen. All right, cool. Today I'm going to talk about one of the services that we launched, AWS. It's Amazon Web Service. Amazon Web Service is the cloud computing part of Amazon.com that we launched in 2006, roughly like this. Our mission in life is make our customers happy and service our customers. So if you know a little bit about AWS, we always work with customer in mind. So I'm going to tackle a little bit that recognition service from a customer point of view and how it helps customers solve their problems. Kai has said already so much about neural network, so it's cutting already 5 or 6 minutes of my presentation, which I'm not going to go there. I'd rather show you some demos or stuff like this. Thanks. Right, exactly. As you may know as well, a lot of the service that we do on the AWS side are services that we expose to customers that have been used inside Amazon.com, right? So we operate, as you probably know, we operate at massive scale. We have quite some weird problem to solve in terms of technology to solve this scale. So we've done a lot of work with, hello. Oh, I'll go there. We've done a lot of work with artificial intelligence. Some of those technologies that you may have heard is in Prime Air, which is doing the last mile delivery of some of delivery in rural area, especially. And you can imagine those technologies are packed full with artificial intelligence. Those drones need to be able to fly on their own autonomously. They need to recognize obstacles and stuff like this. So artificial intelligence and neural networks in particular are particularly good at doing these kind of things. Another technology that you probably heard as well that has been launched in Germany is Alexa. Alexa is something that you put in your home and you can freely talk to it. And it answer questions like, what's the weather? Can you play me the music? And stuff like this. It's totally powered by neural networks as well as artificial intelligence. And those are also some of the things we've exposed to customers. So actually the engine that powers Alexa is also a service called Lex that other customers can use to do their own things. So that's what Amazon does. They take technology and then provide this as a service for our customers. One of the last things that we've done as well with artificial intelligence is this Amazon Go, which is a shop where you would just go and you're monitored by lots of cameras and sensors and all that stuff. All this information is processed inside massive neural networks so that you can just go in a shop, fill up your bag, and then leave the shop without having to go through a queue or the cashier. Everything is automatically done like this. It's still in beta, so there's lots. We've talked about this last night. There's tons of problems to solve, right? So what I'm saying is some of the challenges that we're trying to solve because that's what our customers want. One of the, I think, precursor of artificial intelligence inside Amazon is those robots, the Kiva robots, which are also packing our fulfillment centers. In the fulfillment centers, there's roughly 50,000 of those, just to take your customer package and deliver it, avoid each other. So there's tons of technology inside it to make sure that they don't collide, that they go fast, that they reorganize everything nicely. Artificial intelligence, of course, is there. I'm not going to go through this. What is that? It was a video. As I said, this was the technology a little bit. I was going to discuss about artificial intelligence and neural networks. What I just want to say is this is how a hidden layer works. Basically, it's what you put in between your input and your output that extracts features or artifacts. And the larger your hidden network, or the more hidden layers you have, the much harder it is to compute, right? So for many, many years, there was tons of problems into having the compute capacity to manage those large-scale neural network. This is one of the, let's say, breakthrough in terms of algorithm is really the convolutional neural network, which is really for us in 2000s or the late 90s, was really the breakthrough in taking an algorithm of neural network and making it possible to actually use current compute capacity to train. And those are extremely good to do human-like tasks like recognizing image, speech, or these kind of things. So you can imagine a lot of the technology we're going to talk about today are powered by similar type of technology. There's been improvement in terms of CNNs that have been done and that been added into the technology, but these are kind of the building blocks. And in those building blocks, you of course have training, and in the training phase is also very, very hungry for power, especially GPUs. So if you look at the history, really, 70 years people have been talking about AI, right, neural networks. So really, it's really the advent of cloud computing, basically, that took training and make it available for anyone. So 10 years ago, as a scientist, you were totally not able to buy, let's say, 10,000 instances, 10,000 servers, because you would have to pay for 2 or 3 years, right? Now with cloud computing, you can buy 10,000 servers for a couple of hours, train your models, shut down everything, cost you $1,000. So the advent of cloud computing is pretty much the correlation of why AI is available for everyone. So, you know, it's the sweet spot for Amazon, for AWS, because we have all this capacity, all these services that are there to be used. So AI naturally went with the cloud easily. Of course, data was very important. Digital data, this is used for training. You still need to train those neural networks. They are actually narrow. That means that we need to tell them what they need to recognize in order to have a good neural network. We are not at the GA where generic neural network can start to train by themselves. There are some research into it, but this is not where we are. We are the consumer market, so for us, it's narrow, right? So we need to train everything. Large scale data is now widely available because of cloud computing as well. And lastly, when you want to run your model, it needs tons of CPUs, right? So again, cloud computing is very good for that. Even though now we have a shift towards AI at the edge, so having, you know, IoT with some CPU and power to be able to run those models next to the customer, right? But this is another topic that needs to be discussed. So all with that in mind, the cloud being the sweet spot for AI, we've launched a bunch of services, some very high-level services, so that customers can just use with one API call, send an image, send a text, and something like this. And then there's tons of networks doing things. If you want to generate some speech, you can use Poly. I'll make a demo at the end quickly of that. But today I'm here to talk about recognition, which is the upper left, which is used a lot by companies that deal with media for good reasons. Good reason is that recognition is an image analysis service. You very simply can use it. You send an image to it. There's a bunch of API calls that you can do, and what it can do, it can detect objects and scenes. It can do facial analysis, face comparison. We just launched last week as well, the celebrity recognition, and you can also do image moderation. So you can imagine customers that are dealing with very large bank of media assets find this totally useful. Just to deep dive a little bit about what kind of features that recognition is capable to do with objects and scene. This is an image of Manhattan as well, and we are not actually telling the region where it is for the very reason that was discussed before. We think that location is much better at doing that than AI. So we are more trying to solve the problem of what's in the image versus what's the possible location. We also tend to only return fields or things, or try to guess things that are guessable with mathematics, right? So instead of, I think location is very, very difficult to guess from an image, right? So I don't think it's something that we'll do anytime soon. I might be wrong. Maybe tomorrow we launch that. That happens. But that was my personal opinion, right? As you see, we also return a confidence index. So that means a lot of customers can define what their confidence index is and say, I only use the fields that are upper 70% or 80%. This is the customers that decides we don't do it. We just give you the tools for that. How it works is you send an image, and we'll return just the JSON data out of it. Okay, so very simple, nothing complicated and fancy there. The facial analysis is a bit more fancy in the sense that we also return the bounding box of the head and also the location of every feature of the head. Right? So people have been able to tackle the eyes or the nose, do some changes because they know exactly the location of the nose or all that. We also return the basic emotions and the confidence index of what we think those emotions are. We also have some interesting things like does not have a mustache, and that's our confidence. Those are things that customers have asked a lot. Simply because you can imagine a lot of the apps that are on your phone do a lot of image manipulation for fun things, so people have been asking for that. But media companies have been using this a lot. There's in fact a lot of search on I want images where people do not have mustache or have mustache or beard for some reasons. These are the emotions that we return as well. We also have a confidence index on that. Again, those are the basics emotions. I think there's 6 currently. We also have a facial comparison. So given 2 images, we'll compare faces one to another and give you also a confidence index on that. The API also returns the bounding box of every faces so that you can use this directly with one API call as well to do both face comparison and analysis. That saves bandwidth for your application. The last thing that we launched regarding faces is celebrity comparison. Here, I had to use Jeff Bezos to avoid copyright infringement, and I'm happy I did it after the talk. So this is an image protected by Amazon, so I don't risk to have any problems. But yeah, so basically you just give it an image and we give you the confidence index on that celebrity, right? So in that case, we were pretty much sure that it was Jeff Bezos. The cool thing is we also return head features, all the bounding box, the pitch, inclination of the face and things like this. So you can, of course, adjust that and do image manipulation. Again, this is returned so that it makes life of the customer easier and you don't have to do several API calls to retrieve everything. In fact, you can use the API. You can ask the API to return you all the attributes or not. We have 2 ways of using the API. I'll show you quickly after that. We have an image moderation that was extremely, that was request number 1 from our customers when we launched, is to have image moderation. As you can imagine, it's something which is very, very important. And it's actually been taking off a lot, in particular in India, for some reasons. And I'll show a use case where India, the Tinder of India has used that as a means to do moderation. Those are the explicit fields that we return in terms of nudity or suggestive, right? Again, it's a JSON field, right? So nothing difficult. These are the actions that the API support. I put this there because it's very, I think it's very useful if people are some developers to know what they are. I think what is very important is, at least my favorite, is the one that deals with collection, and this is probably the most used by customers, is that you can create collections of your own images and index people in those images with faces you know. So for example, I've indexed all my library with my mom, my dad, my sisters, and then I can put a picture in my library and the system will recognize automatically if this is from my parent. They are not celebrities, so I cannot use that field. So I need to create the celebrity field for them. But these are something that's been very, very important for community to use and index people that they know. And this few minutes ago, actually, I was asked if recognition is good at handling the challenge that is being put online as a chihuahua. Is it a muffin? So I took on that challenge, and I want to show you live, because I think when you do live stuff, it's when things happen and break. So let's do it. All right, so let's end this show. All right, so this is the console where you can use recognition there, and let's try to upload an image of a chihuahua. I'm sorry, I did do a screenshot of a chihuahua. I'm totally sorry about that, but. All right, so this was one of the images in Twitter that was generating muffins as well. I also took few others just to show how it works. This is actually looking very much more like a muffin, and yet we're doing pretty good at that. I had to use a muffin as well to see if it was doing the opposite as well. And we actually 82%, so you can see there's still the confidence index is pretty high, but it's not at 99%. So it's a very interesting challenge indeed. And I'm happy we managed to do this live successfully. Otherwise, I might have lost my job right away on the spot. What I want to go through then next is how people currently are using recognition. As I said, it's been extremely popular for companies that are dealing with very large media assets. One of the companies here, Binders, that is going to talk about recognition, how they use it. So I'm very happy about that as well. So I'm not going to discuss that use case today. But one that is very interesting is C-SPAN, which is a US company that has used recognition to index every media assets they have, and also videos. They actually extract frames every 6 seconds in the videos, send that to recognition to recognize politicians in videos. And then they can augment the library, the media library, so that when there's something related to a politician, they just can retrieve the entire set of media libraries with one search. And the interesting thing is they did the conversion of their first conversion of roughly 100,000 media assets in just 2 hours. So the API scales, they did thousands of concurrent API calls to the entire API media libraries, and it happened in 2 hours. I think is quite phenomenal. Another case is a marketing company called IPTC, which deals with very large brands, and again they use recognition to handle that. This is the Tinder of India. So for them, this is a place where they can meet. It's a bit more serious than Tinder. It's to meet the possible husband and wife, and people have started to put nude or like pictures of themselves without top. So it was very, very important for them, both in terms of being legally bound to do it, and so they jumped right away on the solution, and now they do 16,000 image moderation per hour or something like that. Pretty insane numbers. You can imagine India is a large market. Yeah, thank you. Just quickly as well, because I've been asked yesterday as well, the pricing, as I say, we are there for the customers. The pricing is $1 for 1,000 image process for the first million, but actually we also have a free tier of 5,000 images per month for the first, for free for 12 months. That's already pretty much a lot. And if you use the metadata storage, so for collection, we store that model or that vectors that recognize the images inside our infrastructure, so that also has a tiny cost. But yeah, thank you very much.